Hi, everyone. Let's start with the session today. So for this session, I've prepared this Prezi presentation. So I'm just gonna play it, and through that, I think my demo is also there. My introduction also is here only. So I'll just start with it, and we'll progress through it. Okay, so hi everyone. Today I'm Jatin. I'm going to present on the topic deep dive into Kubernetes and the containerization concepts. So to introduce myself, I'm Jatin Rajpal. I've got a little over a decade years of experience in IT. I've worked with companies like Fidelity International, United Health Group, and of course now with Blackrock. I started off my career as an Informatica ETL engineer, and then slowly adapted different open source tools like Apache NiFi, Kafka. Also got into the world of containers, Kubernetes, Docker, whatnot. Just as an example, during my last job, we built a complete data ingestion up. We built a data ingestion platform completely based on Kubernetes. And through that, we were moving terabytes of data on a daily basis from our internal systems to public cloud. So that's what it is. Talking about the agenda, today we are going to talk about the containerization concepts. We'll understand how we can, containerize one application via Docker, something called as Docker. Docker again, with that, we'll slowly move towards Kubernetes, which is an container orchestration tool. Essentially, we'll be talking about how a containerized application can be, deployed on Kubernetes. And towards the end, we have a demo. So in that demo, we'll build we will have an application, a Python Flask application. We will run that application first on a local system. Then we'll run that on Docker. We'll containerize it. We'll run it on Docker. And once it is containerized, we'll deploy it on Kubernetes. And that's about it. That's going to be the agenda for today. I'll move forward around the containerization part. So before actually going deep into the containerization, I just want to take a minute talking about why this concept came into the picture. Okay, like think of it like how we are writing our code, like Python, Java, or whatever. We are writing our code and then we are deploying them on our servers. On our servers means the bare metal, the VMs, or whatnot. So that's basically a more traditional or monolithic kind of an architecture. Why I'm saying traditional, because it has certain flaws to it. Your jobs might be, or your applications might be progressing in certain hours in a day. However, your VMs or your servers, they are on completely throughout the 24 hours, and as they are on, you are being charged for it, no matter how less or how more. But yeah, since they are on, they are consuming certain energy, and so you are being charged. And that's where I think the industry is slowly coming into the microservices kind of an architecture. I'll talk a bit about the microservices in a minute, but yeah, just at first we'll try and understand why containerization is needed. So to get rid of this complete charging mechanism, we like came to a cloud native kind of a architecture. When I say cloud native architecture, it means that we should the basic thing about cloud native is it should be able to be port into any of the public cloud, any of the public environment. Then you should only be charged as you're using those infrastructure or basically setup or whatever. So and based on that, the containerization came into the picture. With containerization, post containerization, you can deploy it anywhere. So today's session, it's not just about deploying it on Kubernetes. We'll run it on Kubernetes, but yeah, we'll run it on GitHub Labs as well. So we'll see that part, and through that, we'll be able to prove that we'll be able to container, but with containerization, we'll be able to deploy it anywhere and run it anywhere, kind of like that. And then because it is containerized, the container is only coming once you are possibly it's processing. You can design your application in a way that you are only paying it when you are using it, not for the complete 24 hours, 365 days of like year. That's how it is. And that's where I think the containerization and things came into the picture. Now, like from this containerization perspective, like if I just now take a deeper dive, that was a quick introduction why it was needed. Now, if I take a deeper dive into containerization, what exactly that is, layman terms, in layman terms, we can say that it's a process of building an application, or I would say bundling an application. Okay. So with that bundle, you should be able to take care of all the dependencies. For example, you have your application, which is dependent on maybe, 10 different packages, so you can bundle everything and basically deploy it. That's how your dependencies are basically well taken care of. It would also enable more consistent operation. How I'll say. So with the bundle, you have all the dependencies with you, and you have created kind of like a package. Okay, don't take that as a package, but yeah, I'm just explaining in layman terms, so understand in that perspective. So kind of like a package, and that package is basically something that you can deploy it anywhere, and wherever you'll deploy, it will have a more consistent way of working. Okay, right now you have an application, you have containerized it, you are running on Docker. Okay, it's providing an output, it's behaving in a way, it will behave the same way like how you're deploying it on Kubernetes, or for that matter EKS, AKS, or whatever. Wherever you are deploying it on any of the public cloud, it will have the consistent operation. Moving ahead, it's basically a microservices-based architecture. It's a modern way of how we develop, we do application development. We have come a long way from, monolithic. Monolithic is basically like how we discuss. You have your applications, your big applications. You're deploying them. You're running them, and any small change, it will have a bigger impact. Deploying is a problem. All sort of problems there. And then we have slowly moved towards the microservices based application development, where you, for each component, you have a microservice written. So for example, you have some change, it is not going to be a bigger impact, you just need to replace your microservice and probably like do some enhancement on top of it, so it's easier to manage, is what I'm trying to just say. Last and the very least, not the very least, it's basically like the portability of it. So with that bundling, you should be able to port it anywhere. And that we have discussed it. Like you can port it on any public cloud, you can run it on Kind, Minikube, any Kubernetes instance for that matter. So that's what the containerization concept is, from a concept point of view, and why it was needed. Let me move towards the architecture, the multi-tier architecture, I would say, from this containerization perspective. So think from it like a multi-layered cake. Okay, how the multi-layered cake, and each layer have something for it. So if you see this image on the top right, or onto the down right, on the very bottom you have your hardware. Your hardware comprises of your bare minimum infrastructure, uh, that CPUs, disk, networks, memory, whatnot. So that's everything is here. That's the very bottom of your architecture. On top of your hardware, you have your OS, your host OS and its kernel. Host OS could be, you could use your Linux, you can use your Windows, you can use any OS for that matter, here. So it's basically like the whole OS of your machine. And then on top of that, you have your container engine. And then that container engine could be like your Docker, could be like Containerd, could be Podman, Runc, or anything. That's basically like your container runtime. You can say that your container runtime, your container OS, or whatever. So that's where the magic happens, I would say. And what this container, OS, or container runtime enables you to do is, it enables you to deploy your applications on top of it. Okay, so your applications will run, standalone. I mean, in isolation, but yeah, at the end of the day, it is going to share everything from hardware till container OS. Everything is going to be shared. And that's where the scale comes into the picture. You can do the horizontal scaling. So right now you have one app, and it is just having one replica. You can have 3 apps, and as and when the time comes, as and when your utilization increases, you can horizontally scale your application. So that's basically a multi-tier architecture. I just want to pause here to take any questions that we have so far around the concepts that we've already discussed. All right, I'll move forward. Let me now talk about Docker. What exactly is Docker? We've been talking about Docker. It's container runtime. That's fine. What does it mean? What does it offer? How we are going to achieve the containerization through Docker is what we're going to discuss now. So I think I'll just go at the very bottom of the slide first, and that's how I want to start up this particular conversation. So think of it like a 3 steps. Okay, you build your application. So your application has some code. It has some dependencies. You built your application, and then with building your application, you've created an image, and then you're going to run that image. Uh, After you run your image, you validated everything is fine, then you can share it. Then you can run it anywhere else. And how you're going to do, let's discuss it out now. So the rectangle on extreme left, it's basically the client like us, who developers who are developing their applications. So once your application coding and everything is done, what you can do is you can just build your application through Docker build. So Docker run, Docker build, Docker pull. These are the 3 commands that it offers. Docker offers. Through Docker build, you're going to build your application. And during the demo, I think we'll be able to see how we are going to build that application. But yeah, just be aware of the concept that, okay, first we do the build. Once we are able to build, it creates an image, and everything is honored by this daemon. So this daemon is on the Docker host, the server where your Docker is running, and this will basically honor your commands and will create an image out of it. And with your image, you should be able to do your Docker run, and then Docker run using your image will create the containers. That's how it is. So once your containers are created, your application is all live. You're able to run your applications on those containers. And that's where I think the run part is complete. So build part here we've done here, run part we've run here. And then let's talk about the share part as well. So we talked a bit about the portability as well. So once we have the application containerized, bundled, and bundle is nothing but an image, to be very honest. uh, so once you're able to create a bundle, you should be able to run it anywhere. We discussed it out, right? How you're going to achieve it. Okay, so this is how, hear me out, how you're going to achieve it. So we have something called as registry. So it's nothing but an image registry. Docker provides image registry by default as Docker Hub. Okay, and it's not just Docker Hub, but there are multiple image registries like Artifactory and whatnot that's available. So on this registry is basically like your registry where you push your images. And all the images that you have just now run, through which you've carved out the containers, you can just push it to your registry, and then from your registry you can refer it anytime you want to run it. Think of it like a store, where you are keeping your code, and then you're using your code as and when it is needed. Now it is just not being used for pushing your stuff, pushing your images to the registry. As a matter of fact, we need this registry to bundle our applications as well. I'll explain how. So for example, we talked about bundling up of application. Okay, and then that application that we are talking about, maybe Flask. Okay, let's talk about Python Flask application, the one that we are going to deploy it. Okay, so that Flask application is bare minimum, it is dependent on Flask as a package, as a dependent package. It also needs a Python runtime. Okay, so all that will come from here. Okay, so in our build, we'll pull those images, the basic images, like the Python images, and then we'll deploy Flask on top of it, and then we'll do our application management, and then based on that, the image will be created. So the point that I'm trying to make is, it's not just one way, it's 2 ways. We are pushing our images here, but in turn we are pulling also like the dependent packages that we need to create the images. That's how it works. that's all around the Docker, how we are going to. So in nutshell, there are 3 steps. One, we build. How we are going to build, we'll see towards the end of the demo. I mean, in the demo, we are going to build an application. Once you're able to build it, you just need to run it. How you're going to run it? Through Docker run command. Of course, it's just not Docker run, but yeah, of course, there would be multiple other switches, um, and things like that. I'm not getting into that, but yeah, essentially it's Docker run who's being able to like run the containers or run your image. And then once you're able to run this, you can probably port it anywhere through this registry part. That's about it. Okay, I'll move forward. So the next I'm going to discuss is Kubernetes. So Kubernetes, it's also being called as K8s. Why it is being called as K8s? Because, after K, there are 8 other letters. So the short form is like, it's K8s. K and S is there, just the 8 letters other than these two. So just to give like an introduction about it. So basically Kubernetes was originally developed by Google. Okay. And, they used Kubernetes for around 15 years, 15 odd years. And then based on that, they open sourced this in 2014. What Kubernetes is, it's basically a container orchestration tool. When I say container orchestration, so, and I think during these slides only, I think I'm going to talk about the Docker versus K8. There, I think most of the things will be clear. But think of it like, you have your multiple containers, and then, how you're going to orchestrate your containers, that's basically Kubernetes, takes care of. That's basically the prime job of Kubernetes. So in other words, we can say that, you can group the containers, in a way that, it works as an application and the logical units for the easy management. So you can have your containers running, but yeah, how you're going to group it is would make you like how you're going to easily manage it. And that's what Kubernetes does. Other than that, it also takes care of automating the operational tasks of containers. So for example, your containers, your one of your container crashed because of some issue. Okay, that happens. It happens with our applications as well, running on the bare metal. So Kubernetes itself will take care of the restarts and things like that. So you don't need to take care of the operational task that we are doing as of today. So everything has been taken care from the operational task perspective by Kubernetes. That's about it. Let's talk about the benefits of K8s, the Kubernetes. What are the key features that we are getting alongside? There are many, but yeah, I'm just covering the key ones which are actually relevant to this forum. So the automated rollouts and rollbacks. So we can do, so what do you mean by that? What do I mean by that? So basically like whenever we are in today's world, what we are doing is whenever we are releasing, we are going to have our application downtime. But with Kubernetes, we can do the rolling deployments, which means that we can do the deployments in a way that we don't our like customers don't face any downtime. So for example, you have your application, you have deployed it on Kubernetes, and that Kubernetes deployment have 3 or 4 replicas. What that really means is, your application will run in 4 different, pods. Okay. And then, while you, and then now you are going to release another version. Kubernetes itself is going to, do the deployment in a way that, okay, for example, right now, out of the 4, the 3 are basically inactive. So it will first deploy on the 3 inactive ones. 4th one, which is now going to be, released, is going to be like moved over to one of the 3 which were there as inactive. And then the 4th one is also going to be, deployed. And that's how basically the application downtime is, minimized or mitigated for that matter. That's basically like the rollout, and the rollbacks also can be done in the same exactly similar way. Other than that, it does provide the secret and the configuration management as well. When I say configuration management, basic configuration management, which every code needs, like key value pair. Okay, so for example, you need some key and some value in your code. right now we might create an environment file. You take it from we take it from there, or may create some configuration file. So in exactly similar way, Kate does provide a configuration management thing. So that's called config map. So you can use config map to have your keys and values replaced in your actual code, and that's very much needed for your application to run. Alongside that, it does provide the secret management as well. So for example, you have your user ID's password, database user ID's password, or for that matter, any things that can't be exposed. Okay. So that's something that again you can use. That's something which is available on Kubernetes out of the box. So your user ID, passwords, and everything will be in base64 encoded, and it does provide the basic level of secret management. If you want to take a further step towards it, you can always use some other secret management like Vault, CyberArk, or anything of that sort. But yeah, the basic level of secret management it does provide. The third step that I've mentioned here is, I would say, the most important from a developer perspective. So we have seen that, okay, like our application works in a way that, okay, like we are getting it is maybe it's processing the data on a daily basis, some data in a daily basis, but on the weekend we are getting a lot of data, and that's where I think the resources contentions happen. So in a way, we can say that the application requires less resources on the weekdays and more resources over the weekend, or vice versa. So uh, Kubernetes does provide out-of-box feature that your applications, your deployments can scale horizontally, which means that you don't need to add a lot of capacity there. When you want to scale it, your application would be able to scale on its own. It can maybe use the replicas that you have created, and it has all other ways to scale as well. And definitely that can be coded as per your application. Last but not the least, self-healing. So as mentioned, for example, your pods, some of your pod may get crashed. All the self-healing capabilities Kubernetes provides out of the out of the box. You don't need to do any configurations or like any sort of things for that. Of course, some level of configuration definitely needed, but yeah, the point is it does provide that out of the box. You don't need to write anything for that perspective. That's around the key features of Kubernetes. And I feel this is an important slide from understanding Docker and Kubernetes. If we talk about both of them in parallel, uh, Docker, think of it like you are packaging or you're bundling your application into a box. Okay, so as a byproduct of containerization or Docker, you have created a box. Okay, now once you have created this box, what to do with it? Now one application is in one box. Now you have 4 5 boxes. You have different components taking care of different functionalities. How you're going to run that? And that's where the need of Kubernetes comes into the picture. It enables you to manage the multiple boxes that you've created as a part of your previous step. So that's where I think the Kubernetes will come into the picture. Docker also provides you, and we can also say that it's not an alternative to Kubernetes. However, this is having a different functionality altogether. Kubernetes, on the other hand, it can be used with or without Docker. So Docker, for that matter, have different alternates. Like we talk a bit about it. So like Docker, we have Containerd, we have Podman, we have runc, Hyper-V, Cloud Foundry, whatever. All those are container runtimes. It's not just that Kubernetes only requires Docker. You can use any of the container runtime. Only thing is it requires the container runtime. And that's where the second statement has come. Kubernetes can be used with or without Docker. Docker to containerize your application. Definitely, it's a container runtime. Whenever we are containerizing our application, we are using it. Kubernetes is to run them at scale. So scale, this is something that we discussed, right? When we are having our containerizing application and we want to run them at scale, Kubernetes is the right platform for it. So a highly configured Kubernetes environment is capable of processing huge data and kind of very resource intensive workloads at very ease if configured properly. That's basically the scale that we're talking about. Docker, the last point, it's an industry standard. When I would say industry standard for packaging and distributing the applications. Kubernetes is, again, it's an industry standard to deploy and manage your application, containerized applications at scale. That's where the high level difference of Docker versus Kubernetes, came. That's about it from the theory part. I would again want to just, wait for any question if you have. Is Flask is also a container OS? So Flask is not a container OS. Flask is a dependent, package for your application. The other question by Dinesh is, can Kubernetes manage simple code on server? So server is not coming into the picture now. So your server is replaced by the containers. Yes, definitely it can. And we'll see towards the demo that, how it is going to manage a simple code. Other question is how we can deploy a containerized application on AWS Lambda function or a Google function. Okay, that is again a serverless function that we're talking about. So when, again, I think, yeah, that's a very good question, I would say. So when we are able to containerize our application, Dinesh, we'll be able to, deploy it, serverless. And as you mentioned, that AWS Lambda or Google function, for that matter, they are like serverless platforms. So on the serverless platforms, it just requires your, application image. With that image, it takes your image and just provides the runtime for it. You don't need to maintain a Kubernetes, instance for that. You should be able to use these and you should be able to deploy it using the image. Okay, I'll move forward. Next, I'm going to, start with the demo, what I've planned today. So what we're going to do is we are taking a simple Python Flask app, first we're going to run it locally on my Mac. And then, we'll just containerize it and run it first on Docker. Once we are able to run it on Docker, we be sure that, okay, we are able to containerize it. Then, we take that image and we'll deploy it on Kubernetes. Deploy it and run it on Kubernetes. So that's how we're going to do. Let's start with it. And for it, I think this is something that I would just want to say, that this is a GitHub repository that I've created. It has all the steps. So I'll request mods to kind of share this repository and the slide deck to you guys so that you should be able to run it on your systems, as you need that. Okay. So we'll be able to share this across. Okay. Okay, let's start with the first step. Okay, let's first talk about what exactly it's there in this repo. So in this repo, basically you'd see three folders. Like our goal, let's talk about our goals first. Our goal is to basically take an app, first run that app locally, okay, then run it on Docker, then run it on Kubernetes. And exactly that is covered in 15 steps. So 15 are the total count of that steps, right? And then those 15 steps are categorized into, how the high level 3, run locally, or basically then you run it on Docker and then you deploy it on Kubernetes. So the 15 steps are then categorized, but on a high level, it's basically just 15 steps that you have to, run. If I go on top, you'll see three directories here. Okay, one is your application directory. The application directory is there for running the application locally. It contains your program, and that is basically a simple Python program which just renders this index.html. That's about it. Then, templates contain that HTML file. Then within the Docker directory, you have your Docker file. You have your application code, which is like a template and program. Now, like, what is a Docker file? And this is definitely needed, if we have to containerize an application. Okay, we'll discuss one when we basically discuss about the containerization of this particular application. So this is particularly for, running this application on Docker. Again, go back on the root. And then the third folder that you see here is the kh-config, which contains the deployment, files for Kubernetes. So we'll discuss about these as well once we talk about once we deploy this on Kubernetes. Now, first step towards it, we clone this repo. So how we are going to clone it? We are going to, so I've mentioned it here, but yeah, you can do this as well. So you can just go to your local HTTPS, copy it from here and do the git clone for it. And definitely this requires a git client for you. So make sure that you have it before you run this command, otherwise it will fail. So once you do that, so we ran git clone and it cloned my repo. Okay, I've got my repo here. First, we are going to run it. We're going to run the app locally. So, you just traverse into the app folder, app directory. You'll see your program here. So what you need to do is you need to export this environment variable Flask app. And then you just do Flask run. Okay, it should run. So my API is live. We can just do curl -v. Sorry about that. Curl -v. You see, I have a hit on my application, and it returned the HTML file that I have here. So which proves that I'm able to run this app locally. So now that I'm able to run my application locally, I know that this is the code that I have. It actually works. Okay, now my code is ready. How I'm gonna containerize it? Okay, how I'm gonna containerize it? Let's discuss it out. And this is basically the important part. So navigate to your Docker folder. Now that you have navigated to your Docker folder, you'll see different things here. You'll see a Docker file, which is the most important, what I would say, block that we need to kind of understand. If we have to, containerize an application, we have to create this Docker file. Okay, what this Docker file actually contains, it contains the instruction how you're going to, run this and how you're going to bundle this. So my application for that matter, it requires a Python. Okay, so Python 3.9 Slim Buster. This is nothing but the image name for this Python like application. And then you created /app. It's basically more of a work directory, where you're going to run it. It's all visualize. You have to do that. Okay, first you'll take how you're going to do it manually. You are just going to visualize it and put it there on the Docker file. So you've chosen this image. Over that image, you've created this /app. Then you did a run pip install Flask, which is basically like I just downloaded the dependency for my application, and for my current application it's Flask. You might come across a scenario where you have maybe hundreds of dependencies. So you can always write a requirements.txt and you can do run pip install requirements.txt. It will take all the requirements from that requirements.txt and will just download them. Then you copy everything that you have in this directory to /app. Okay, when I say dot, it means that it is going to copy everything that we have here. Like for example, within the Docker directory, you have your program and your templates. It's going to move under /app once it runs on a container, and that's how you're going to move your code. You're exposing a port which your application needs. Okay, then you're setting an environment variable like how I set it while I was running it. And then you just run your command, how you're going to run it, Flask run, and then host and port. This is completely optional, but yeah, essentially you just need to do a Flask run. That's about it. So think of it like a instructions. Okay, that how Docker should run your application. So that's what you need to probably do. So once you're able to create this Docker file, right, what exactly we need to do? Let's go back to your GitHub repo. I'll go back to my README because that contains all the instructions. Okay, so after that, you need to do Docker build. And that's basically what we discussed previously as well. So we did a Docker build -t, and then that's the name of your application. Dot contains, that, okay, you are, whatever you have in the current working directory, everything you want to take and build a demo app, basically. This will take some time. It will, generate, it will build your application. It will pull different images that are required, your dependencies and things like that from the image registry, and it will create an image. Now, what is an image? It's not something that you can see here. Okay, how you're going to validate your image is basically mentioned next step. So as a byproduct of this step, Docker build, you should have your image created. And how you're going to check your image, you just need to do Docker image ls. Okay, Docker space image space ls. With that, it is going to list all your images. Okay, so demo app is what I built, because it already had it on my system. So it didn't had any change. So it never, bothered about, changing the created timestamp. But essentially, you don't have this demo app, so you'll have it like few minutes ago. Typically how, I have mentioned here. So when I added these texts here, 8 seconds before I created those images. So it contained 8 seconds ago. And that's how, you should also get once you, possibly, do the Docker build. Okay, now your Docker build is complete and you're able to see the demo app on as one of the image listed in your, on your system. Then you're all good to run your container. Okay, Docker container. How you're going to do? You're going to do that through Docker run command. So the command is Docker run -p is for port, and then, your image name. So with Docker run, I'm able to run my application. I'm going to just validate through the same curl way like I did. Curl -v. Okay, so I'm able to see the output HTML index.html, which means that, it is working. And we've also got a hit here, the HTTP hit. So we can see that, okay, my application is up and running from a Docker perspective. We've been able to run the application on Docker. Going back, this part I've already done, like the curl part. I got my index.html, which means that, okay, my application is running. Now that my application is up and running and I'm able to up and running on Docker, which means that, I'm able to kind of containerize it. How I'm gonna run, I'm going to run it on Kubernetes. The next two steps are really that I can't do because, the uh, image is already there on my Artifactory or my Docker Hub. But this is essentially that you have to do. Okay, first you have to tag your image. Okay, after you tag, so how you're going to tag it? So Docker image tag. So this is basically the command, and then you have to like tell what is the name of your image and what name probably you want to push your image. So once you run this, you create a tag, and once you are able to create a tag, you should be able to push your image to your Docker Hub. Now, having said that, this requires you to create a account on Docker Hub beforehand. So like I mentioned the Docker Hub URL here. So before running it, you make sure that you complete your registration, create an account, and then that account name is something that you have to use here in Docker push. Only then you will be able to push your image to the Docker Hub. So now that my image is pushed to Docker Hub, you should be able to, through these commands, we can just do the deployment. How we are going to do the deployment, because right now I don't have any Kubernetes running. So basically, I'll be making use of Minikube. Minikube is, kind of a scaled down Kubernetes cluster that you can use on your system. So we just do a Minikube start, and it will be able to, it'll take a few seconds or something, and it'll be able to start a Kubernetes cluster on the system. Okay. Now I can do minikube status. Okay, so everything is up and running. So these are like a Kubernetes components, and I don't see any problems here. I don't see any errors or something. Uh, Now that my minikube is started, my Kubernetes cluster is started on the local system. And for that matter, just I want to give one more information. Minikube is a Kubernetes instance, but it is like a scaled down version Kubernetes, and it is using Docker. So if you see a Docker, if you do a Docker PS, you will see that Minikube is running here. Okay, so this Kubernetes itself is running as a Docker container, kind of like that. So Minikube also requires Docker to be installed on the system. Just be aware of that. Now that my Minikube is started, okay, I can just go to the kh-config directory. Now I'm in my directory. Okay, now let's talk about what these deployment, YAML is. For example, now that your application package is there, okay, you have to deploy it on Kubernetes. How you're going to deploy it? You're going to deploy it through this deployment YAML. This one really is not important, but let's talk about this one. I think it's better I open from the GitHub. So you see here, basically this is like my deployment YAML. And this deployment YAML will give you an instructions, the Kubernetes, like how you're going to deploy your image. Okay, that image that is there on the Docker Hub. So the first kind that I have here is, and this is really like two YAMLs consolidated into ones. For you to run any other application, you just need a deployment YAML. But yeah, I'm using a Flask application, which is basically a web service. So for web service, I need a service as well. So I needed two YAMLs, but I consolidated everything in one YAML. Essentially, you can break this in two as well. Okay, one for service and one for deployment. So this API version is what is common across. The kind is what we need to basically see. So this is my deployment kind, and this is my service kind. Okay, deployment is basically like what deployment you want to do. You're going to name a deployment. What is the name of your deployment, then how much replicas you want to set. This is a basically what I would say, a YAML that you can take from Kubernetes documentation, and you could just fill it. And then the spec part, which is basically important. You're going to have details applied to containers. What is the name of your application? What is the name of your container? Then what is the image that you wanted to use? This image you've already used or pushed in the previous step. So you're just going to give a reference that, okay, Kubernetes, take this image from this Docker Hub repository and use it. And image pull policy, like every time we are running it, it always pulls the policy, like the image. If you don't use that always here, it is going to cache it, and it is going to use the outdated, if at all you are pushing updates to your image. Then what are the ports that you're going to need for it. For us, it is 8,000. So that's around the deployment part. You have your service part as well, like what kind of a service that you want to basically create. I'm creating a load balancer. You have multiple services option, like node port and everything, and those are really the deep dive. I mean, I would not want to get into that because it's just an introduction part. Services are many kinds. We can always refer Kubernetes documentation for that. But for our case, we have used load balancer. So metadata name, like our application name, then spec within spec app, the port, the target port, and the protocol. And of course, the most important of it, type. You can use node port, you can use load balancer. For us, we have used load balancer. That's what your configuration YAML would look like. Now I go back to my instructions. I'll just do a kubectl apply. Kubectl is again one of the command line which is provided through Kubernetes. Through Kubernetes, kubectl command line binary should be able to deploy your application. So you just need to do kubectl apply -f and then reference your configuration YAML. So once you do that, you see that okay, your demo app is created. That's your app, and then your service is also created, demo app service. So that's what I could see. Now I'm just gonna do the validation. Kubectl get svc, which is to get the services. So I could see that okay, demo app is there. However, pay very attention to pending. The external IP is pending, which means that right now I would not be able to externally access this service. Okay, we'll see how we are going to enable the external part as well. But essentially, I'm able to see my service. Now, how I'm gonna see my deployment. I can see that demo app is deployed. It's ready, up to date, available 44 seconds ago. And as a part of the same deployment, we'll be able to see the pods as well. So all my pods are up and running, which means that my deployment is successful. Now that my deployment is successful, still I'll not be able to call my service externally. I'll be able to call it internally from internally, and that's what I have BusyBox as well for it. Again, a different concept. I don't want to maybe get into that, but yeah, essentially from internal to the Kubernetes, I'll be able to access my service, but externally I'll not be able to, because my external IP is not there. I need ingress controller and things like that for that. For Minikube, I think we have a way. We have something called as Minikube tunnel. So I've done all these validations as a part of listed as a part of step 11. So then we can just use the tunnel, which is to just basically what I should say, make it available externally. It's one of the Minikube specific commands. So once you do the Minikube tunnel, it creates a tunnel. It uses your service name. My service name is demo app -svc, demo app -svc, and it created a tunnel for it for everyone to connect to it. Now I can't do a control C on it because it will use this. It needs to be like stay live to be able to for us to connect to it. I'll use the other terminal to again do a kubectl get svc, yeah. So previously we saw that okay, we were getting this demo app svc pending, okay, the external IP pending. Now I've got the svc demo app -svc external IP. I can now use it because of the tunnel. So again, I'll do curl, sorry about that, curl -v and the local host 6000. Cool. I'm able to get the index.html, which is needed. And that's how, we saw that, we are able to like connect to the pod, and we are able to, connect to my web service externally outside the Kubernetes cluster. And that's how basically like we are able to prove that, the application which we ran first locally, then we, containerized it. Now we are able to run it on Kubernetes. Now that it's done, it's more of a hygiene step 15th one. So like every time you do a deployment, you make sure that, you delete a deployment. Sorry about that. Otherwise it is going to and delete svc also. Let me delete. And then I've got a message, service deleted, app deleted, Minikube delete. That's more of a hygiene. But essentially, yeah, this is what I had for demo. Any questions that we have? Okay. Is Kubernetes open source? Yes, it is an open source tool. How it can be accessed? So you can always, deploy Kubernetes like I did, Minikube start. just as a prerequisite, probably you can refer to the Minikube documentation. Minikube documentation is mentioned on my GitHub only. So you can go here and you can always, do a Minikube documentation, go to that. And through that, I think you'll be able to, deploy Kubernetes, at least for your learning. That's how it is. So that answers your question, how it can be accessed. Okay, I've got a question around CI/CD part of it. So Terraform, yes, Terraform can be used, Ansible can be used. There are many ways you can use, like many tools that you can use these days. But yeah, Terraform and Ansible being the closest, like the most widely being used alongside Jenkins. Then I've got a question, how is Docker image different from Amazon machine image used in AWS? Docker image, again, I think it's the same thing. It's just a different terminology. So for example, like if I talk about Kubernetes, the AWS implementation of Kubernetes is EKS, Elastic Kubernetes Service. Azure implementation of Kubernetes is AKS, Azure Kubernetes Services. And that's how basically they have their own patented technology. But end of the day, it is Kubernetes only. So basically, yeah, that's what. Can Kubernetes monitor services or send alerts or on SMS and email? Yes, I think it can do. There are different other things that you might need to use. So for observability, it's basically a very wide topic. I would not want to cover it here, but on a very brief level, from observability standpoint, we can have something called as Prometheus, Thanos, and we can use Grafana. And through these tooling, we should be able to, set up a complete um, what I should say, observability for your containerized application. For that, I think you need to maybe change some, what I should say, design pattern as well. So one of the design pattern is like sidecar implementation. So your sidecar implementation will make sure that whatever stats you are basically generating as a part of your application will goes into your Prometheus, and then your Prometheus will, your Grafana will actually show the stats from your Prometheus. That's how it is. Is Linux preferred for deployment? So you can use any OS. OS is not an issue basically, but yeah, I'm more familiar towards Linux as throughout my career I've used Linux only. But yeah, actually you can use Windows as well. That is not an issue. Okay, I think these are the questions that I have here in Q&A section. I'll just stop share and maybe just we want to, like, if there are any other questions I can share, otherwise I can take, otherwise we are bang on time. So nothing more to be discussed. Okay, cool. Thanks so much.